Welcome to lesson number 4. Today we're going to look at logarithmic functions. Alright, so let's jump into it. So we're going to explore the exponential function of y is equal to 2 to the power of x. And what we want to do is explore the inverse of y equals 2 to the power of x. So remember, when we're looking at inverse functions, then all we're really doing is switching our x and y values so that our x's become our y's and our y's become our x's. So if we wanted to determine the inverse of y is equal to 2 to the power of x algebraically, then the inverse, we would just switch the x and y values. So x would then equal 2 to the power of y. But if we were to rearrange this, we're going to run into a problem where, well, how do we get rid of an exponent, my exponent of y? How do I set this equation equal to y? And so that's the difficulty that we're going to run into is we can't set our equation equal to y. And so at this point, we're unable to write the inverse of our equation in terms of y. So we can't solve for y. And in this lesson, what we're going to do is we're going to look at, well, how do we actually write the inverse of an exponential equation? So let's take a look at part 2. And to determine the inverse of y equal to 2 to the power of x graphically, we switch the x and y coordinates at each point on the graph to produce the graph of x equal 2 to the power of y. So the first thing we want to do is let's graph this equation. So 2 to the power of x, and we're going to get something that looks like this. And so we're given a table of values here that we need to fill in. And so let's start at x is equal to -3, and we get 0.125 or 1/8. And as we move down our table of values, we'll just input our values of y accordingly. So at -2, that's at 1/4, and -1, I'm at 1/2. And again, I'm just following all these values. So at 0, I'll be at 1. All right, and now what we want to do is plot this on the graph. So I know that my y-intercept is going to be at 1. And at -3, I was at 1/8. -2, I was at 1/4. At -1, it was at 1/2. At 0, I was at 1. At 1, I'm going to go up to 2, 4, 8, and then 16. And so it's going to look something like this. And this is the graph y is equal to 2 to the power of x. Alright, and so if we were to graph the inverse, we know that our x and y values switch. So if I look at what happened to my y values, now all my y values are the same as my x values were with my regular function. And so that means that all my x values are going to become what my y values were. So that's going to be 1/8. That'll be 1/4, 1/2, 1, 2, 4, 8, and 16. And so now I can plot those according to my graph here. And so at y is equal to -3, I was at 1/8. Down here at 1/4, I was at 2. At 1/2, I'm at 1. At 2, I'm at 1. Sorry, 2, I'm at 1 up here. At 4, I'm at 2. At 8, I'm at 3. Now, if we're looking at these graphs, then you might notice that at y is equal to 2 to the power of x, I have a horizontal asymptote where this line isn't actually going to cross the x-axis at all. And with my inverse function, x is equal to the power of y, I also have an asymptote, but this time I have a vertical asymptote where I'm not going to cross the y-axis. So if I were to state the line of symmetry for the equation, my line of symmetry is going to be running straight through y equals x. Alright, let's move on. So y is equal to 2 to the power of x is the exponential function, and we know that this has a base of 2. The inverse of this function is x is equal to 2 to the power of y, and it's also a function, and it also has a base of 2, but we can't write it in terms of y. So what we're going to do now is look at the logarithmic function, in which case we are able to express it in terms of y. So a logarithmic function, or a log function, is the inverse of an exponential function. So the inverse of the exponential function with base 2, example, is y equal to the power of x. And the logarithmic function, which is the inverse of the exponential function with a base of 2, can be written as y is equal to log 2 of x. And so the graph for y is equal to log 2 of x is going to be the same as the graph of x is equal to 2 to the power of y. So and remember, this is the inverse of y is equal to 2 to the power of x, just what we looked at the other example. And so x is equal to 2 to the power of y can be rewritten in terms of y, so we can solve for y as y is equal to log 2 to the power of x. And so in general, we write y is equal to log b of x rather than x is equal to b to the power of y to express the inverse of y is equal to b to the power of x. Now, when we're writing these types of equations, these log functions, the inside of the logarithm, so the x, is known as the argument. And this x value can never be negative. The b value, that's going to become the base, and that's going to be the same as the base for the exponential function. So in the previous example, we looked at a base of 2. And then y is the value of the logarithm. That's what your logarithm equals. Okay, so let's look at this example. And it's the same one we looked at previously. We have the graph of y is equal to the power of x, and we have x is equal to the power of y. Okay, so there's our two functions. The first thing we want to do is write the label y is equal to log 2x beside the appropriate graph on the grid. So remember that this is the inverse of this function up here, so that means that it must be this one. So log 2 of x. And then next thing we want to do is just complete this table at the bottom here. So if I'm looking at this first graph, y equals 2 to the power of x, the domain, since that my values of x are going to be infinite going this way and going in this direction. So I know that my domain is going to be elements of real numbers. But remember what we looked at previously where we had a horizontal asymptote on this line, but with our inverse function we had a vertical asymptote. So I know that I can have any value of x for my domain as long as it's going to be greater than 0. So I know that x has to be greater than 0, and I know that x is also going to be an element of real numbers. But my range, let's look at the range now for both of them. My range for my regular function y equals 2 to the power of x, notice how it's not going to go below this line because I have a horizontal asymptote here, so it's just going to be opposite. My y has to be greater than 0 such that y is an element of real numbers. And just like my domain was an element of all real numbers here, my range for my inverse function is going to be an element of real numbers as well. And so if I look at the x-intercept, remember that this one doesn't actually cross my x-intercept, so there is no x-intercept here. But if I look at my x-intercept for my inverse function, I'm crossing it at 1. So my x-intercept is going to be 1. But the y-intercept for my y equals 2 to the power of x function, I cross at 1, and this one, because I have my vertical asymptote, there is no intercept. And now if I look at the actual asymptotes, y is going to be equal to 0, and in this case, x is equal to 0. Okay, so all of them are opposite because they're inverse of each other. Okay, let's look at this at class example number 2. We're given two graphs. We're given y is equal to 2 power of x, and we're given the inverse y is equal to log 2 of x. Now we have the points 3 and 8 on the graph of y equals 2 to the power of x, and that indicates that 8 is equal to 2 to the power of 3. All we did was we substituted the values of x and y into our equation of x and y to give us 8 is equal to the power of 3. And the point 8 and 3 on the graph of y is equal to log 2 of x indicates that 3 is equal to log 2 of 8. And so again, all we did was we substituted the values into our x and y values. And so with that being said, what statement can be made from the point -2 and 1/4 on the graph of y equals 2 to the power of x? Well, again, if we substitute these values in for x and y, I know that y is equal to 1/4, so I know that 1/4 is going to equal 2 to the power of -2. And this makes sense, right? Because if we were to rewrite this using a positive exponent, 2 to the power of -2, I would find that I had 1 over 2 squared, which equals 1 over 4. Now, what statement can be made from the point 16 and 4 on the graph of y is equal to log 2 of x? Well, that's my x value and that's my y value. And so 16, that's going to be the value of x in my equation. I'm going to substitute that in for x. And I know that log 2 of 16 is going to equal 4. So we'll keep practicing in converting from logarithmic to exponential form. And so here, remember this is the argument. This is the value of x in our equation if we wanted to convert this to exponential form from log form. And so now if I were to convert this is my value of x. So what we're actually doing is we're converting from log form to exponential form. We're converting it to x is equal to 2 to the power of y, or whatever our base is to the power of y. And so now I want to rewrite this in log form. It's going to be log, or 4 is equal to 2 to the power of 2, since log 2 is equal to 4. And all we're doing is we're looking at at this table in order to solve. So if I was looking for log 2 to the power of 8, I know that this is where my y value was. And so for log 2 of 4, I look for what my x is for, and I look for what the argument or what the value of my log is, and that is y, and that was equal to 2. And so now let's look at this next one, log 2 of 2. Well, at log 2 of 2, I know that this is equal to 1. So that's my value of x, that's my value of y. And so I can rewrite this as 2 is equal to 2 to the power of 1. Log 2 of 1, again, I'm going to look up here. Well, when x is equal to 1, then y is equal to 0. And so if I were to rewrite this, that's going to be 1 is equal to 2 to the power of 0 in exponential form. And now we're going to go backwards. We're going to go from exponential form into log form. And so 1/4 is equal to 2 to the power of -2. Well, remember that this is my my argument. So that becomes my x value, and this is in exponential form, it's also my x value. And we're working with a base 2 here, so this is just going to be log 2 of 1/4, and that is equal to -2, which was our value of y. And then the last one, we have log 2, and this becomes my argument, 1/2, and that is equal to -1. Alright, so in class example 3, what we want to do is we want to use the same pattern in order to rewrite the exponential statement 10 to the power of 3 is equal to 1,000 in log form. And so remember that this is another way we can write this is 10 to the power of y is equal to x. And so in log form, this 3 becomes my y value, this 1,000 becomes my x. So log 10 of 1,000 is equal to 3. And finally, we want to go backwards and put this into exponential form from log form. And that's my argument. So x, we're going to go, in this case, we go, since that's my base, 4 to the power of y is equal to x. And we're going 625 is equal to 5 to the power of 4. All right, let's look at the last couple pages now. All right, so let's just look at some characteristics of the graph of the log function. Y is equal to log b of x. So the x-intercept is going to be 1. There's no y-intercept because it doesn't cross the y-axis. So if we were to make a quick graph of a log function, it's going to look something like this. So that's going to be 1, the x-intercept. Remember, because of our vertical asymptote at y equals 0, there is no, x equals 0, there is no y-intercept because it doesn't actually cross the y-axis. And so the y-axis is a vertical asymptote with equation x equals 0. Our domain, x has to be greater than 0 because it doesn't actually cross into this side, and the range is an element of real numbers because it can be anything from negative infinity to positive infinity. Alright, let's look at some more examples now. Class examples 4, 5, and 6. So we want to state the inverse of the following functions, answer in the form of y is equal to whatever. Alright, so y in this case, if I'm stating the inverse, I want to state what the exponential function would be. So remember that this is the base, so we know that that's going to be the base of my new function, and my value of x is going to remain a value of x. So in this case, it's going to be 3 to the power of x. If I want to go backwards, so I want to do the inverse of my exponential form, this is going to become y is equal to, this is going to stay my base, and so remember the base of the logarithm goes down here, and the exponent becomes your argument. That's going to be x. So we're doing the same thing, converting from log form to exponential form. And so x is equal to 7, that stays my base, to the power of 4. This is my x value, so that's going to be 15 is equal to my base 5 to the power of y. That's my x, so b is equal to my base of t to the power of m. And what we have to do here is divide both sides by 4. And so if I divide this by 4, I'll be left with 5/4 is equal to my base, which is going to be b to the power of, oh, sorry, I mixed that up a bit. 5/4, but this is my x value, so I want my x on this side. X is equal to my base b to the power of 5/4. Now convert each of the following from exponential form to log form. Okay, so if I'm converting this to log form, remember that this is going to be my x value, this is going to be my base, and this is going to be my y. So I'm going to be left with log 4 of x, 64, is equal to 3. Same thing here. This is going to be this is going to stay my base, my y, and my x value. So I'm going to be left with log 2 of 1/8, and that is going to equal -3. Same thing, we have our base, our y, and our x, so I'm going to have log e of f is equal to d. Now, this one may look a little tricky, but what we have here is it's written kind of backwards, so that's my x value, my b value, and my y value. So I have log a of 2x plus 4, and that is equal to 5. Alright, so last few examples. We want to calculate the value of t if log 2 of x is equal to 3 and log 2 of t is equal to x. Alright, first thing we want to do is rewrite this. So if I have log 2 of x is equal to 3, well, I know that if I were to rewrite this, I would have x is equal to 2 to the power of 3. Right, because x becomes my argument, and remember that I could rewrite this so my base is the same, and that is the exponent of y. And so if x is equal to the power of 3, that means x is equal to 8. And now I know what my value of x is for this new equation. So log 2 of t is equal to 8. And now I can convert this again into exponential form, right? Because I have my statement of 8, I have my value of t, which is the same thing as x. So t is equal to my base of 2, that becomes my exponent of 8, 2 to the power of 8 is like 256. Is 256. Now, let's just, the log form of y is equal to a b to the power of x. So what we've looked at to this point is the exponential form y is equal to b to the power of x, and the log form log b of y is equal to x. Now we want to consider how to write the exponential form y is equal to ab to the power of x in log form. So this can be done using this following procedure. We can write the form y is equal to ab to the power of x as y divided by a. So all we did was we wanted to get this b to the power of x by itself. So we divided it by a, and we're left with y divided by a is equal to b to the power of x. And now we can change y divided by a is equal to b to the power of x to log form. And in order to do that, the log form of this, or this, is we would take b, remember, becomes our base, so log b. This becomes our argument, y divided by a, and we are left with our exponent, and that is equal to x. So let's do a few examples. I'm just going to do these two, and then you'll be able to do these other ones. So first thing I want to do is divide this by 2, and I'm left with 3 to the power of x. Now I can rewrite this in my log form. And so log, and remember this becomes the base for our log. So this is going to become log 3. This is our argument, y divided by 2, and we're going to set this equal to x. And this one over here, well, if I divide this by 3, 2, I'm actually multiplying my y by 2/3. So that becomes 2/3 y is equal to 10 to the power of x. And remember that this becomes our base in our logarithm. So log 10 of 2/3y is equal to x. And I'll just do one more. I'll do this one over here. And so I'm going to divide this side by 7. This becomes h divided by 7 is equal to 4 to the power of k. This 4 becomes our base, so I'm left with log 4 of h over 7, and that is equal to k. And lastly, we'll do 2 examples over here where we're going the other way. So we're converting from log form into exponential form, in the form y is equal to a b to the power of x. And so if I were to rewrite this, remember that this y over 3 becomes my y value, and the 7 was my base with my x as my exponent. Now all I need to do is multiply this by 3 to get y by itself. This becomes 3, 7 to the power of x. 3 times 7 to the power of x, sorry. So we'll do the same thing over here. Y over 4 is equal to, this becomes my base, and this is my exponent, 10 to the power of x. If I multiply both sides by 4, this is going to become y is equal to 4 times 10 to the power of x. And let's see which one would be trickier. I'll do this last one for you as well. And so y divided by 5 is equal to my base, in this case is e to the power of x, and multiply both sides by 5, I'm left with 5 e to the power of x.